So once again, what is difference of squares? Difference of squares is when you have two square terms and they are subtracting. Okay, so examples of difference of squares are x squared minus 25, x squared minus 100. So a generic way of them writing difference of square is usually they write it as a squared minus b squared. So this is telling us that both these terms have to be perfect squares. So that means I should be able to take a square root of them. That's condition number one, that I should be able to take a square root of them. They should be perfect squares. Okay? So what do I get from square root of a? It's a squared, it's a, and the square root of b is b squared is b. So you write that twice, and then you put one negative, one positive, because that's the only way you can have a negative in the middle. So first, these should be perfect squares. That means I should be able to take a square root of them. Second, they should have a subtraction sign in between. If you don't have a subtraction sign, you cannot do difference of squares. Okay? So here's some examples of where you cannot do difference of squares. So these are not difference of squares scenarios. Okay? So let's say if you end up seeing something like this, x squared plus 25. So first check, can I do the square root of x squared? Yes. Can I take a square root of 15? Yes. But the problem here is that the middle here is addition. So this one, you cannot do difference of squares. So you actually cannot factorize this any further at all. Okay? So this is not a difference of case scenario. Let's take a look at another case. So what if you have x squared minus 14? So can I take a square root of x squared? Yes. But can I take a square root of 14? No. It won't give you a whole number. So again, so you cannot do this, and the problem here is the fact that this is not a perfect square root. And that means we cannot do anything else with it. Okay, so let's give another example of something that is a difference of square root then. Okay, so like they gave over here, it's fine. How about if you have numbers 4x squared minus 9? So the condition is, can I take square root of both these terms? Yes. What will they be? It would be 2x and 3. 2x and 3. And because this is a negative here, one will be negative, one will be positive. Okay. Think about why they can't be both negative. Because if they're both negative, let's say if these negative 3 and it was also a negative 3, it would multiply to become positive 3. And the middle terms will not cancel out. So these two conditions are set. We cannot change them. Okay, so let's try them in some examples here. So example number 1 is right here. So again, check, are these both perfect square roots? Can I take square roots of them? Yes, they're perfect squares. And there is a negative sign in between. So that's all I need. So square root of a squared is a. The square root of 4 is 2. So we write that twice, and then you put one negative, one positive, and we're done. Okay, I find this to be the easiest factoring that we can do. Okay, so again, can I do a square root of these two? Well, yes, t squared becomes t, and 144 becomes 12. So if I write that twice, and then one positive, one negative. So you'll notice it doesn't matter which one you put first. Okay, next one here, square root, yes, x squared and y. So we write that twice, one positive, one negative. Okay, d is also the same thing, just written a little differently. Remember, I can take a square root of p is p squared is p. The square root of 7 squared is just a 7. So instead of writing like 49, they're trying to trick us and they're writing as 7 squared. But I know the square root of 7 squared is just 7. So that's perfectly okay. So one negative, one positive. Okay?